Lesson number 7 on matrices. So we are going to look at matrices as operands. So matrices can be used or can be applied in other areas of mathematics, like in consumer arithmetic and solving simultaneous linear equations. So we can use it in linear equations only. So we use the inverse of a matrix to solve a simultaneous linear equations. Let's look at the following example. Solve simultaneous equations 3x plus 2y is equals to 0, 2x plus y is equals to 1. Therefore, the first step here is to form a matrix. So here will be we have a square matrix here, 3 on the upper left, 2 on the bottom left, 2 on the upper right, then here it's 1 on the lower right. So we take the coefficients only. Step number 2, then we find the inverse. So let's form a matrix here. You can see that we just take the coefficients. Then here we have a column matrix, or a column vector with x and y, which is equals to another column matrix of answers 0, 1. So here you must find the inverse. y, because we are dividing this matrix both sides. So here it becomes an inverse multiplying this matrix. So the inverse results in an identity matrix here. It will give us 1, 0, 0, 1, which will give us x and y, and here it will give us the values of x and y. Let's calculate an inverse. So our determinant here was -1, therefore -1 divided by 1, or 1 divided by -1, it is -1. Then our inverse, these two swap, is 1, 3, then the signs changes, -2, -2. So this will multiply both sides. Let's multiply both sides with this. As we said before, that on this side it will give us an identity matrix, which is 1, 0, 0, 1. Then on this side it will give us the final answer. So let's concentrate on this side only to find our answers. Here we already know that it will give us an identity matrix. So in identity matrix here, 1, 0, 0, 1, xy. Therefore let's multiply here row by column, then with -1, or we can factor in the determinant here, the inverse of the determinant into the matrix as a scalar, like this. -1 times -1 is -1, -1 times -2 is +2, -1 times -2 is +2, -1 times 3 is -3. Then our answer here is 0, 1. So let's simplify here, row by column, -1 times 0, which is 0. Then 2 times 1, which is 2. 2 times 0 is 0. -3 times 1 is -3. So this will be our final answers for x and y. So here this represents the value of x, this represents the value of y. Therefore x is equals to 2, y is equals to -3. Let's look at another example to make it easy to grasp. Here is half x plus 3y is equals to 4. Then we have 3x plus 2y is equals to 8. Let's form a matrix here by taking the coefficients. Half, 3, 3, 2. Then here on answers is 4, 8. Then we have a column matrix for the algebra. Then let's find the inverse. The determinant here, half times 2 is 1, 3 times 3 is 9, so it's 1 minus 9, which is equals to minus 8. So our inverse will be 1 over minus 8, then it's 2 minus 3, this changes the sign, this changes the sign, this swap, this 2 and half, then minus 3, then this multiplies our answers to give us the results for x and y. Therefore, let's factor in this color first. Minus 8 times 2, 2 will cancel 8 to give us 4. This will become minus a quarter. Minus 8 times minus 3, this will become positive 3 over 8. This will become positive 3 over 8, and this will become minus 1 over 16. Since minus 1 times 1 is minus 1, 8 times 2 is 16. Then we multiply by our answer for 8. Therefore, row by column, minus a quarter times 4 plus 3 over 8 times 8. Let's do that. So here you see that we'll cancel here, we have minus 1 plus 8 will cancel here plus 3. Therefore, here also you can see that 3 over 8 is multiplying 4 minus 1 over 16 is multiplying 8. So let's simplify this. You can see that 4 will cancel 4, 8 will cancel 4, then 4 into 8 is 2, 8 into 16 is 2. So therefore here is 3 over 2, here it's minus a half. So this will be our values, minus 1 from here plus 3 from here. Since these 8 cancelled each other, then here 4 cancels 8 to give 2, so this becomes 3 over 2 plus minus, this will become a negative. 8 will cancel 16 to give 2, so this is minus a half. Therefore, minus 1 plus 3, 3 over 2 minus half. So this will give us positive 2, this will give us positive 1. So these are the values for x and for y. So x is equals to 2, y is equals to 1. So this is our final answer. So that's how we use matrices to find the values of the variables in a simultaneous equation. Few things to do: solve the following simultaneous equations using the matrix method. So this 0,4 plus 3y is equals to 2,6, x minus 2y is equals to 4,6, 3x minus 2y is equals to 9, 4x plus y is equals to 1.